So good day. So this will be week 9 for the general mathematics learning competencies. Illustrate the different types of tautologies and fallacies. Determines the validity of categorical syllogisms. Establishes the validity and falsity of real-life arguments using the logical propositions, syllogisms, and fallacies. So start with the definition. A proposition that is always true is called the tautology. Well, the proposition that is always false is called a contradiction. So we denote the tautology symbol. We have already established this type of propositions in week 8. But to give you a preview of this one, how to determine if the given compound proposition is a tautology or a contradiction. Construct a truth table to determine if the given compound proposition is a tautology or a contradiction. So, as we all know, there are a series of what we call operations. So we have and, not Q, then close, then and, then we have P and Q. So this will be conjunction, negation, close, then we have conjunction, closed by the conjunction of P and Q. Now, since we have two propositions and we expect to have 4 rows, we start with the column of P. 4 rows, 2 true and 2 false. Then for the column of Q, alternate the true, false, true, false. Then to establish now the third column that is not Q, so we have the negation of Q. So not Q, this one, not true is false. We have not Q is false, not false is true, not true is false. Then we have not false is true. Then we're going to have this first, what we call this one, the first operation, compound operation. So we have this column. So we're going to have P. So this will be our concern. P and not Q. And we have the operation, which is conjunction. So if both of the propositions are true, then the conjunction is true. Otherwise, this will become false. Okay, so true, false, there is the presence of false, therefore, your final answer is false. True, 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 going to true is true. Then this one, false, going to false is false. Then false and true will become false. So this will be the column of P and not Q. Then establish now the next operation, which is the P and Q. We have this. The column of P and Q. So we're going to have this, what we call the P and Q. So this will be our concern. The P and Q. So we have the P and Q. So we have P and Q. Still, this will be conjunction. Both of them are true. So true, true. Therefore, conjunction says that this is true. We have the presence of false. True, false. Then this will become false. Then we have also false here. false true, and the operation is conjunction, therefore this will be false, then both of them are false, then this will be false. Then we're going to combine now this operation. So this will be the operation. Sometimes you can say table that D reflected this one as the column of R. R is equal to this one. R is equal to this whole propositions. But in our case, we have the basic. So we have this operation. So our concern now is having the two column, the P and not Q, N. So we have N because we have the presence of conjunction. And this one. So false and true will become false because conjunction says if both of them are true, then the statement will become true. Otherwise, this will become false. True, false will become false. Then both of them are false. Therefore, automatic and conjunction, we have false and false. So this column now, this operation resulted to all of values are false. Therefore, this will become a false combination. False for any combination of truth values of P and Q. Therefore, the given compound proposition is an example of contradiction. Moving on, construct a table to determine if the proposition P implies P or Q, or P then P or Q. So how many propositions we have? So we have P and Q. So we have two propositions. So we have 4 rows. Start with the P, having 4 rows, column P. So we divide the true and false. So 2 true and 2 false. Then establish now the column of Q by having alternate value of true, false, true, false. And we're going to establish this P or Q. So this or now is what we call disjunction. As we all know in week number 7, we have P or Q. So as long as we have true, the statement will become true because the presence of or. This will become false if and only if the given 2 statements are false. So true or true is true. True or false, we have true. And the final answer is false, true is true. Then both of them are false. Then this statement will become false. Using this compound proposition, by having this column, we can have this. So our concern now is between P and P or Q, but the operation is a biconditional. P, then P or Q. So the most important thing that we have is the conclusion is true, then the statement will become true. Or if both of the conclusion of the hypothesis and the conclusion are false, then this will become true. Okay. So we have, if the hypothesis is true, but the conclusion is false, then this will become false. Okay, so let us have this. True, then true, therefore, this will become true. Your hypothesis is true, then the conclusion is true, therefore, automatic, this will become true. your hypothesis is false, but the conclusion is true, then this will become true using the biconditional. Both of them are false according to biconditional. Once this is false, both of them are false will become true. So any combinations are true. Therefore, the given compound proposition is an example of tautology. This is an example of tautology. As long as we have true in the last column of the operations, then we can say now that this is a tautology. Now, what is the use of tautology? What is the use of the concept of contradiction? So in week 9, we're going to emphasize the importance of your knowledge in having the contradiction and tautology as your basic requirements in moving week 9. Okay. Let us have this proposition. We have P, not P or Q, then P, then Q. So we're going to say that if this first column will be your P, so that will be basic, and Q will be your second column, we're going to negate now the proposition of P by having this column. Okay, so this will be negation of P. So this is true, therefore the negation of that is false. This is true, negation of true is false. This is false, negation of false is true. Then this is false, negation of false is true. So this will be the column of not P. Then afterwards, perform now the operation of not P or Q. So this will be a disjunction. Okay. Not P and not Q. Okay, so let us erase this one. So not P and not Q. So this will be not P or not Q. So the concern is not P and Q. So true is true. As long as we have true, then the statement will become true. This will become false if both of them are false. That will be the concept of disjunction. So false will become false. True, so we have the presence of true, both of them are true, and we have false true, we have the presence of true, and this is disjunction. Therefore, this statement will become true. Next, we have here P implies Q. So this is biconditional. So this will be your hypothesis now. Okay, so this will be your hypothesis, and this will be your conclusion. So P, then Q. So let us erase this in. Okay. Having this column, so this will become your hypothesis. This will become your hypothesis. And this will become your conclusion. So by conditional, this is true. The hypothesis is true and the conclusion is false. Therefore, it is important to have conclusion, so this is false. The hypothesis is false, but the conclusion is true. Therefore, this will become true. Both of them are false, then this will become true. Okay. Next, we're going to combine now. We're going to combine now these compound propositions by having the last column. So all in all, this will become your hypothesis column. And this will become your conclusion column. So by conditional, P implies P, then Q, true, true will become true, false, false. Then the operation is this one. Therefore, this will become false. Both of them are true, true. Both of them are true. So we have the true column. Next, regardless of the truth values of the P and Q, given the compound propositions is always true, so we can consider now that the compound proposition is an example of tautology. Syllogisms. Syllogism is a form of deductive reasoning where you arrive at a specific conclusion by examining two other premises or ideas. So syllogisms derive from the Greek word syllogismos, meaning conclusion or inference. Some syllogisms contain three components. Okay? Major premise, minor, and a conclusion. If the value of, using the Venn diagram states that if A is a part of C, then B is a part of C. Then we have, for example, all roses are flowers. This will be your major premise. This is a rose, and this will be your minor premise. Therefore, I am holding flower is a conclusion. So, note that the first proposition is the major premise, the second is the minor, and the third is a conclusion. The type of syllogism that typically contains these three components is what we call categorical syllogism. So we have major, minor, and conclusion. So that is what we call a categorical syllogism. So categorical syllogism, as we know, our first example about roses was a categorical syllogism. Categorical syllogisms follow if A is a part of C, then B is a part of C. So, logic. Now, let us look at some more example of syllogism. All cars have wheels. I drive a car, therefore, my car has wheels. The major premise of this one is all cars have wheels. We have this major premise. I drive a car is a minor premise. Then the conclusion, the word therefore, my conclusion, my car has wheels. So this is an example of categorical syllogism. All insects frighten me. That is an insect, therefore I am frightened. So the major premise of this one, all insects frighten me. Minor premise, this or that is an insect. And conclusion, I am frightened. Okay. So those are a given example of categorical syllogism. Later on, we're going to have those important concepts in proving such validity of an argument. An argument is a compound proposition of the form P sub 1 and P sub 2 until P sub n, close, then Q. So the propositions of P sub 1 and P sub 2, then P sub n, are the premises of the argument. and Q is the conclusion. That's why we have already established what is meant by categorical syllogism. There should be premises before we're going to have conclusion. An argument can be written into propositional form, column, or standard form. So the given example, the previous example, this is an example of propositional form. But this example is the standard form. Okay? Now, example. Explain why the following set of proposition is an argument. If General Antonio Luna is a national hero, then he died at the hands of Americans in 1899. General Luna is a national hero. Therefore, General Luna died at the hands of Americans in 1899. Okay. So let us have this one by one. If we're going to consider now the first statement as the first premise, the piece of one, okay, the major premise, if General Luna is a national hero, then he died at the hands of Americans in 1899. The second premise, General Luna is a national hero. The conclusion is Q. Therefore, General Luna died at the hands of Americans in 1899. So Q now will serve as your conclusions. Okay? In symbols, we can write the whole argument in propositional forms. We have this, the P, then Q, N, P, then Q. And in standard form, we have P, then Q, P, therefore Q. Now, how to determine if the given statement is a valid argument? Okay. Okay, so let us continue. How we're going to have determine if the given statement is a valid argument. Okay. So let us have this argument. Example. Prove that the argument P, then Q, and P, then close, implies Q is valid. This argument is known as the Mujos ponens or rule of detachment. Okay. The first column is P. Then we have 4 rows because we have 2 propositions. So true, true, false, false. Next is we have the Q, which is true, false, true, false. Next, we're going to establish now this P implies Q. So this will be your hypothesis and this will be your conclusion. Okay, so true, true will become true. True, false, the conclusion is false. Therefore, this will become false. False, true, the conclusion is true. Then this will become true. Both of them are false. Then this will become true. Next. We have to establish also the column of P, then Q, and P. So let us have this. So our concern now is this column going to this column. And the operation is conjunction. In conjunction, we use the knowledge by having, if the two propositions are true, then this statement will become true. Otherwise, this will become false. So we have this. True, true. So true and true will become true. Then next, we have true, false. We have the presence of false. Therefore, this will become false. Then we have false, true. We have the presence of false, which is this one. Therefore, the statement will become false. False, false, then this will become false. So we have established now the P implies Q, close, and P. Okay, so let us continue. We're going to have the complete operations by having this value going to Q. So this will be now what we call your hypothesis, and Q now will be your conclusion. So let us have this column. So your hypothesis is true because the presence of this will become hypothesis, and this will be your conclusion. True, then conclusion is true, therefore this will become true. False, then the conclusion is false, therefore this will become true. False, then the conclusion is true, and this will become true. Then false, false, we have true. Now, this column, this operation ended with a combinations, any combinations are true. Therefore, we can say now that the given compound propositions is an example of tautology. Therefore, the given proposition is an example of a valid argument. So, valid argument follows the concept of tautology. Any combination must be true. Moving on. For the definition, a valid argument satisfies the validity condition, that is, the conclusion Q whenever the premises of P sub 1, P sub 2 up to P sub n are all true. Alternatively, the argument is valid if the conditional of P sub 1 and P sub 2 and P sub n implies Q is a tautology. And we have already established in this table using the modus ponens or rule of detachment. Moving on. Okay, let's have this example. If Juan and Pedro are friends, then they are Facebook friends. Juan and Pedro are not Facebook friends. Therefore, they are not friends. Okay. Let's establish this one. The solution, let P, Juan and Pedro are friends. Then Q, Juan and Pedro are Facebook friends. Okay. Now, we have the presence of are not. So you negate, no? That's why negation of Q is are not. Okay. Then the given argument is P, then Q. Okay. So we have the symbol like conditional. So it will be your P, then Q. Not friends. So we have not Q because this will be our Facebook friends. Not Facebook friends is not Q. Therefore, this is a valid by modus tollens by not P. Okay. Now, what if the argument is not valid? Let's continue. Is there a possibility that the argument is not valid? Okay. Let us have. By definition, an argument of P sub 1 and P sub 2 and P sub n implies Q, then Q, which is not valid, is called a fallacy. Okay. In a fallacy, it is possible for the premises P sub 1, P sub 2, and P sub n to be true, while the conclusion Q is false. In this case, the P sub 1 and P sub 2 and P sub n implies or then Q is not a tautology. So, prove the argument. So let us have this example. Prove the argument using this compound proposition. Or is a fallacy. This is known as the fallacy of Converse. Proving. We're going to determine if this compound propositions is a fallacy using the converse of fallacy of Converse. Okay. First column, P and Q. Next, we're going to have the P then Q. So this will be your hypothesis and this will be your conclusion. Okay. So true, true will become true. True, false. The conclusion is false, then the statement will become false. False, true. Since this is true, conclusion, then we have true. Then both of them are false. Therefore, this statement now will become true. Next, we have here N, not Q. So we have this column. So by having this column, we're going to use this one, then Q column. And we're going to use the operation of and or conjunction. As long as both of them are true, this will be the concept. Then the statement will become true. Otherwise, this will become false. Okay. So, we have P, then Q. So we have this. P, then Q, going to Q. Okay. So true, true will become true. False, false will become, this will be false. Okay, this will be false. Okay, then true, true will become true. Then false, true will become false. Okay, so we have true, false, true, false. Next, we have the last column, which is a combination of the two. So we have this one going to P. So this will become your hypothesis and this will become your conclusion. Okay. So true now, going to true, yes, true. False, true, the conclusion is true, therefore this will become true. Then false or true, false will become false. Then false, false will become true. Okay, so let us try to observe. The last column give us true, true, false, true. Then the given is not a tautology. The argument now is invalid. Hence, this is a fallacy. So if the argument is not valid, then this is a fallacy. How we're going to determine now if the statement or the argument is valid using the table, it will ended up with a tautology, then the arguments are valid. Otherwise, this is a fallacy. So thank you for watching. Good day.